Hello and welcome everyone. This is a short tutorial on solving for the minimum spanning tree of a weighted graph using Kruskal's algorithm. Let's begin with the weighted graph data structure. We know that a graph consists of a set of vertices, such as the circles that I'm drawing here, and a set of edges, which connects pairs of vertices. Recall that this graph is weighted, so we must also assign integer-valued weights to each edge. We'll write 6, 1, 5, 5, 5, 3, 6, 4, 2, 6. And this is the weighted graph that we will reference throughout the rest of this tutorial. Next, we define a spanning tree. A spanning tree is simply an unrooted tree that spans the same vertex set as its referenced graph. Here's an example. We begin by drawing the vertex set of our original weighted graph. Then we select edges from our reference graph such that we generate a tree. So here is one particular set of edges that generates a tree. And notice that we pull all of these edges from our referenced weighted graph. This is a spanning tree. However, a graph may have multiple spanning trees. Here's another. Draw the same vertex set, of course. And let's say we select these particular edges with the corresponding weights. Since there are potentially many spanning trees, we would like to find the minimum among them. The minimum spanning tree should minimize over the sum of the edge weights. As an example, consider the first spanning tree that we've drawn. The sum of the edge weights is 19. And for our second spanning tree, the sum of these edge weights is 21. And Kruskal's algorithm is a procedure to solve for the minimum spanning tree of a weighted graph. So let's begin this procedure by drawing the original vertex set. And now the algorithm begins by selecting the lowest weighted edge, which in this case is 1. And for each edge selected, we accept it if it does not create a cycle, where a cycle may look something like this, or perhaps even longer like this. These are cycles. Cycles are bad. We don't want cycles. Then we proceed with the next lowest weighted edge and ask if it creates a cycle. If it does not, we accept it, such as this 2 here. We continue. Take 3, it does not create a cycle, therefore we keep it. Take 4, it does not create a cycle, therefore we keep it. And now let's try selecting one of these 5s here. Well, this 5 here creates a cycle, so we shouldn't keep it. Go ahead and remove this. And now, can we take this 5? This 5 also takes or creates a cycle, so therefore we cannot keep it either. However, we can take this 5. And now, note that when all vertices are connected, you're done. So the sum of these edge weights is actually 15. This is how you can solve for the minimum spanning tree of a weighted graph. I leave it to you as an exercise to solve for the running time of this particular procedure now. Thank you. I hope you found this tutorial useful.